Hello class, batch 24, year 4. Dr. Abriza here to present part 2 of Fluorides lecture. The topic that will be covered are 1. Water fluoridation, 2. Toxicity, 3. Issues and challenges. At the end of the presentation, it is hoped that students will be able to explain systemic fluorides methods of delivery in relation to water fluoridation and describe fluoride toxicity as well as methods of measurement of fluorosis. What is fluoridation? Fluoridation is the controlled adjustment of fluoride to public water supply. Fluoridation acts as a public health measure for the prevention of dental caries, and it is the most cost-effective method of fluoride delivery to the population regardless of age and socio-economic status. The history of water fluoridation dates back to 1901 when Dr. Mackay discovered permanent stains which the locals called Colorado stains. This is later known as mottled enamel. Dr. Mackay found that domestic water is the primary cause of mottled enamel. To establish a geographical areas of mottled enamel, Dr. Mackay contacted G.V. Black in 1916. After detailed examination of mottled teeth from different places, histological findings were published in 1917 as endemic imperfections of enamel of teeth. The United States Public Health Department appointed Dr. Dean to research on mottled enamel in 1931. The survey conducted was called the shoe leather survey. It is to study the relationship between fluoride concentrations in drinking water, mottled enamel, and dental caries. Severity of mottling increases with increase in fluoride concentration in drinking water. In the mid-1940s, researchers investigated cities that had both fluoridated and unfluoridated water. And the first pair that they investigated was in Michigan, between Muskegon and Grand Rapids. Following that, Grand Rapids became the first community in the world to add fluoride to its drinking water. That is in 1945. The history of water fluoridation in Malaysia dated back to 1957 when Johor became the first state in Malaysia to have water fluoridation. This is followed by Penang in 1959 and Sarawak in 1961. In 1969, the Committee on Fluoridation of Public Water Supplies in West Malaysia was appointed to study and report on the feasibility of introducing the fluoridation of public water supplies as a public health measure. In 1972, the Malaysian Cabinet approved the addition of fluoride to the public water supplies. Fluoride concentration in water. In 1958, WHO report that 1 parts per million had marked preventive effect on caries, and controlled fluoridation of drinking water was a practical an effective public health measure. In Malaysia, water fluoride levels are kept as between 0.5 to 0.6 parts per million. Previously, the optimum level was 0.5 to 0.7. After a review in 2004, considering the consumption of alternative sources of fluoride in the population, the fluoride level was changed. Maintaining optimal fluoride levels in the water supply is important to achieve maximum benefit to oral health and safety. Fluoride concentration in water varies with temperature. Therefore, in cold climate, it is recommended to be at the level of 1.2 parts per million, whereas in extremely hot climate, the level is at 0.7 parts per million. High temperature increases mottling as water consumption containing fluoride increases, leading to fluorosis if taken during enamel mineralization. Fluoridation does not affect the appearance, taste, or smell of drinking water. It is normally accomplished by adding one of the three components to the water. Sodium fluoride was the first compound used, and it is easily handled and usually used by small utility companies. However, it is more expensive than the other compounds. Fluorosilicic acid, which is widely used in the United States, contains so much water that shipping can be expensive. Sodium fluorosilicate is a powder or very fine crystal, also known as sodium silicofluoride. In Malaysia, the fluoridation pump uses sodium fluoride and sodium silicofluoride. There are many types of equipment for water fluoridation. The saturator system consists of 4% saturated solution of sodium fluoride. The limitations are high hard water level and need to clean the gravel bed used for filtration, and is recommended in small towns. The dry feeder system uses sodium fluoride or silicofluoride powder. Its limitation is that obstruction of pipes, compacting of fluoride when stored in humid atmosphere, and recommended in medium-sized town. Solution feeder uses hydrofluorosilicic acid using volumetric pump. Its limitation is that the equipment must be resistant to hydrofluorosilic acid, and it is recommended in medium-sized and large towns. Venturi fluoridation system is a non-electric system. Its limitation is that the equipment must be resistant to the acid and activated by flow of water in main water lines. The cost is 2 out of 3 of the convention equipment and easy to install. Then we have the saturation suspension cone, which consists of upside-down cone charged with a bag of sodium silicofluoride through which a constant flow of water percolates. The cone must be of corrosion-resistant material. When we think of water fluoridation, the water authorities always think of the cost. So in Hong Kong, an annual cost of lab equipment is about $7,000 per year. And in USA, it is estimated at 0.35% per year of the cost of water fluoridation. In Malaysia, that is in 1972, per capita cost was 16 cents per person per year, and it increases to 46% per cent per year. Limitation of water fluoridation is that it requires centralized pipe water distribution system. A number of studies were done. This is one of the studies done in Johor in 2003 to look at the cost of per capita per year for 0.7 parts per million, and it was estimated at 0.17. But this does not include capital costs. There's another type of water fluoridation, which is specifically called in the school. So it's a school water fluoridation. It is an alternative to community water fluoridation. The recommended fluoride level in school water is about 4.5 to 6.3 parts per million. The effectiveness is about 40 to 45% reduction of the DMFT at 5 parts per million of fluoride. The school fluoridation. In 1965, Horwitz et al. Discovered that greater than 22% less DMFT in fluoridated school compared to other schools. And in Pike Country, Kentucky and Elk Lake Peninsula, in 1968, it was found to be about 33% and 35% reduction after 8 years. None of the students developed fluorosis after exposing to 6.3 parts per million of fluoride for 8 years. Fluoride toxicity. Fluoride is used extensively in practice of dentistry to reduce incidence of dental caries. However, excessive use of fluoride can produce toxicity and even lethal outcome when ingested or inhaled or absorbed into the body. The toxic effects of fluoride is mainly due to 4 different actions. There is the burning of the tissues, impeding nerve functions, cellular poisoning, impeding cardiac function. The severity of fluoride depends on the concentration of fluoride in drinking water, the period of exposure, climatic factors, fluoride ingestion through other sources, nutritional status, chemical constituent of drinking water, and the occupation. The effect of fluoride at various concentrations. So depending on the dose of fluoride, we will have to see the effects. So 1 part per million causes dental caries reduction. If more than that, we will get motile enamel, osteosclerosis, thyroid changes, growth retardation, kidney changes, and this may be lethal in causing death. Fluoride toxicity can be grouped as acute and chronic. Acute is whereby a single large dose within 2.5 to 5 grams, whereas chronic toxicity will occur when more than optimal level for a long duration, which will result in dental fluorosis and in skeletal fluorosis. Acute toxicity can result from dose of fluoride intake starts from certain levels of fluoride. This is we have to look at the body weight of the child. So it is approximately 2.5 to 5 grams of fluoride in children and 5 to 10 grams in adult. Chronic fluoride toxicity can result, as I have said earlier, in dental fluorosis for concentration greater than 2 parts per million and skeletal fluorosis for concentration of more than 8 parts per million. Occupational skeletal fluorosis occurs in workers in aluminum industries, magnesium foundries, fluorspar processing, and superphosphate fertilizers industries. This is an example of skeletal fluorosis, whereas in more advanced cases, there's calcification of the ligaments resulting in ankylosing spondylosis. The signs and symptoms of fluoride toxicity are gastrointestinal, neurological, cardiovascular system, and blood chemistry. Dental fluorosis. What is dental fluorosis? Dean in 1934 defined dental fluorosis as a hypomineralization of tooth enamel or dentine by the long continued ingestion of excessive amounts of fluoride during tooth development. Whereas Murray in 1986 defined it as a specific disturbance of tooth formation caused by excessive intake of fluoride during formation period of dentition. There are a number of possible mechanisms of dental fluorosis. In mineralization, there is irreversible effect, the existing mineralizing matrix. There is a interferes with deposition of crystals in the new matrix and reduce the available ionic calcium, resulting in reduced proteolytic activity. Fluorosis occurs when fluoride interacts with mineralizing tissues, causing alterations. In enamel, fluorosis causes subsurface hypomineralization or porosity, which extends towards the dentinal enamel junction as severity increases. Early maturation stage of enamel formation is particularly sensitive to fluoride exposure. Development of fluorosis is highly dependent on dose, duration, and timing of fluoride exposure. The risk of enamel fluorosis is lowest when exposure takes place only during the secretory stage. Exhibits less fluorosis than their permanent successors, but the distribution within dentition follows similar pattern. This is the distribution of fluorosis in primary dentition. The reason is because the placenta acts as a selective barrier and most calcification occurs before birth. Distribution within dentition follows similar pattern as in permanent dentition. The assessment of fluorosis is difficult in primary dentition because there is a thinner enamel and the incremental line is often lacking or less pronounced than permanent teeth, and it gives a more subtle appearance. Distribution of fluorosis in permanent dentition. Posterior teeth are more affected both in maxilla and mandible. Fluorosis occurs symmetrically within the arch, the premolar, second molar, maxillary incisor, canine, first molar, and mandibular incisors. The indices for fluorosis. There is a number of index that can be used. So first is the Dean's fluorosis index, and the modified one which was in 1942, and we all have other indices. Indices for fluorosis in terms of descriptive, we have the DDE or developmental defect of enamel index. Now we shall talk about Dean's fluorosis index. It is introduced in early 1930s. The 7-point ordinal scale and each tooth is rated according to the scale. This is the original criteria from normal to severe. The modified form of the Dean's Fluorosis Index was introduced in 1942. It is a 6-point ordinal scale and is extensively used today. And the scoring system is from 0 to 4. 0 sent to normal and 4 for severe. This is the Dean's Fluorosis Index. So in 0, usually we have a translucent semi-vitriform and is smooth and glossy. There is an intermediate stage which is questionable, which is actually a slight aberration from the translucency to occasional white spots. Very mild, which is 1, which is small opaque paper white areas scattered irregularly over the tooth, not involving more than 25% of the tooth. Whereas mild is indicated as 2, which is more than 50%, less than 50% of the tooth, with white opaque areas. Moderate, we find that all enamel surfaces of the teeth are affected. There may frequently be found brown staining and a disfiguring feature. In the severe, which is noted as 4, all enamel surfaces affected and is marked hypoplasia. We have to differentiate between dental fluorosis and enamel opacities. The characteristics that we look out for are the area affected. So, in enamel opacities, usually centered in smooth surface of limited extension compared to dental fluorosis. The lesion in enamel opacities, they are mainly round or oval. And the color is creamy yellow to dark reddish orange at the time of eruption. The teeth affected are mostly the labial surface of single tooth, which is mostly the incisors. This is another two-surface fluorosis index delivered by Horowitz et al. In 1984. So the scale is 0 to 7. The prevalence of fluorosis. A lot of studies have been done to look at the prevalence. That is, in the earlier part of 1970s, the Dental Division of the Ministry of Health conducted a study and found that there is no prevalence among the 6 to 18 years old. And other studies conducted shows an increase in the amount of fluorosis prevalence. And 30 to 50% prevalence reported for optimally fluoridated areas in USA. So the treatment of fluoride toxicity is to reduce fluoride absorption, increase fluoride excretion, and plasma potassium and calcium monitoring. The management of toxicity is based on the amount of fluoride ingested. The table shows the different type of management and with regards to the amount of fluoride ingested. Management of dental fluorosis. We have 3 lines of management. 1 is preventive, number 2 clinical treatment, and number 3 is defluoridation. Preventive measures is follows strictly recommendations by the authorized bodies, the ADA, on the use of fluoride dentifrices, mouth rinses, and supplements in children, and also fluoride supplement schedule. For the clinical treatment, for fluoride toxicity, as stated, there is a number of clinical treatment which is done. And in dental fluorosis, there is tooth whitening, bleaching, crown, veneers and laminates, and also the use of composite restorations. Defluoridation is another line of treatment. In what is defluoridation? It is a downward adjustment of fluoride ion concentration in public drinking water supply so that level of fluoride is maintained at the normal physiologic limit of 1 part per million to prevent dental caries with minimum possibility of causing dental fluorosis. There are various defluoridation techniques which has been explored, and each has its limitation. So the techniques are adsorption. This can be achieved with locally available adsorbent materials with high efficiency and cost effectiveness. Precipitation. It is the most well-established and most widely used method, particularly at community level. Ionic exchange removes fluoride up to 90 to 95%. However, it is relatively expensive. Membrane process. It is effective and do not require chemicals, but the higher cost and require skilled labor. Calcium amended hydroxyapatite. It is a most recent defluoridation technique in which aqueous calcium is amended to fluoride-contaminated water. It provides calcium-enriched alkaline drinking water and may help in fluorosis reversal. Monitoring of fluoride concentration in water. In the Ministry of Health, monitoring of fluoride levels is done at 2 levels. One at the water treatment plant, the other at the reticulation points, and it involves a number of agencies. Issues and challenges of water fluoridation. Adoption of water fluoridation requires political process that make the establishment of this public health measure difficult. Furthermore, opponents of water fluoridation often made unsubstantiated claims about adverse health effects of fluoridation in attempts to influence public opinion. Example of this is by the Consumer Association of Penang, whereby issues of ethics, effectiveness, efficiency, and cost effectiveness, necessity, safety, equity, and the scientific basis for fluoridation was questioned. The major issues pertaining to fluoridation program is to have an optimal level in order to keep the fluorosis prevalence down. Cost effectiveness, reinstating discontinued fluoridation programs in private water treatment plants, acceptance of monitoring levels by water authorities, and compliance by water treatment. There are many public systems which are not fluoridated and tend to serve small populations. This increases the per capita cost of fluoridation. To overcome the challenges facing this preventive measure, public health professionals at national, state, and local level will need to enhance the promotion of fluoridation and commit the necessary resources for equipment, personnel, and training. Normally, we find that at the fluoridation plants, there is always a breakdown of the feeder equipment, inadequate maintenance, and analysis of the equipment is not functioning, and inconsistent scheduling of fluoride analysis. The accuracy of the calorimeters, different types used, inadequate stock of sodium fluoride, temperature closure for upgrading and renovation work, inconsistent dosing, lack of supervision of workers, long storage of water samples between time of collection and testing. Therefore, the strategies to ensure compliance of optimal fluoride levels at reticulation points is that prompt repair and replacement following breakdown of feeders, maintain spare sets of analysis equipment in case there's any repair to be done, and the sodium fluoride powder, there should be sufficient supply and timely collection and proper storage. Centralized training on policies and benefits, safe handling, proper and correct procedures, and the maintenance of calorimeter and availability at the site and the clinic. Because normally sometimes the clinic has a different type of calorimeter compared to the testing done at the plant itself. Water sample collection points. Similar collection points by both the health and the water authorities. Ensure the reticulation points are free from mixing of water. And there should always be monitoring. It's either online or visits and reports of the visit. So issues has to be discussed regarding calibration and maintenance of fluoride feeders, and the calibration and maintenance of analysis equipment, and calibration ought to adjust for fluctuations of output capacity, thus leading to accurate dosing. Maintenance will ensure removal of unwanted residue of fluorides and sediments from feeder and the doser. Concerted efforts has to pool from all the past, present, and future research pertaining to fluoride. And we should have a data bank in which there is a proper what do you call that, data, so that everybody can make use of the data in order to improve the fluoridation program. These are the challenges, because there's a lot of research done, but the availability of data is difficult. And the vigilance on fluorosis prevalence and severity as the biomarker on fluoride use. And we have the vigilance on fluoride levels in toothpaste. In this presentation, these are the two main references that was used. And with that, I thank you all and wish the best of luck for batch 24 year 4. Bye.